Hello everyone. Today we will start the second part of numerical control part programming. So in previous lecture we have discussed the basic of the NC part programming and G code, M codes. Now we will discuss the different programming format. So there are different variables like machine tool, setting, offset, like different work to be done before starting the programming. So in basic the in this slide we can see the so here we can see the word address format is like this. So whenever we start making the manual part program, so we write in this order. So like one particular, this is the one line of a program. So here we can see this is the representation of like number of or lines programs, then G code, then spindle in X direction, Y direction, then feed, speed, and this is tool number. M09 is used for coolant turn on and off. So this is the complete we can say format of a line of a program. So here we will see the machine tool 0 point setting. So usually to for this particular thing for make the or for prepare for that machine tool to for 0 point set, we use two methods. So once it's done by the operator manually. So manually by a programmed absolute zero shift or by work holding system. So in manual setting, the operator can use the machine control unit control to locate the spindle over the desired part 0 and then set the X and Y coordinate registers on the console to 0. So it's completely done by manually by the operator using the machine control unit. He locates the spindle by the control panel and it's done completely manually. Second method is absolute zero shift. So the absolute zero shift can change the position of the coordinate system by a command in the CNC program. So the programmer first send the machine spindle to home 0 position by a command in program. Then another command tell the MCU how far from the home 0 location and the coordination system origin is to be positioned. So here this thing done by sending some kind of programs to machine spindle to set the home 0 position. And we can see there are different we can say point. One R represent reference points. This is the maximum travel of the machine. There are for workpiece W part 0 point workpiece coordinate system. Third is machine M 0 point setting where we represent X0 Y0 Z0 of the machine coordinate system. So the sample command we use for this particular zero shift like N1 G28 X0 Y0 Z0. This is the command we send the spindle to home 0 position or for returning to reference point. Again, for the position of the machine that will reference as a part 0 or program 0 shift, we use as a command N2 Z92 X0 Y0 X. This is the position we need to move. So we do this or we send this particular command. So particularly if we we register for home for register for the position, then we use G92, and this is for home position G28. We use this particular command. Next thing is coordinate word. So as a coordinate word, the specify the target point of the tool movement or the distance to be moved. The word is composed of the address of the axis to move and the values and direction of the movement. So for example, like x 150 y minus 250. So that represent the movement of the x axis and y axis in this direction or in this particular. We can say this is the movement we want. So whether the dimensions are absolute in capital, that we will have to define previously using G codes. Next thing in programming is parameters for circular interpolation. So these parameters that specify the distance measured from the start point of the arc to the center. So we use particular numeric I, j, k or the x, y, z component of the distance respectively. So there are other terms like spindle function. So the spindle speed is commanded under an S address and is always in revolution per minute. So it can be calculated by the following formula. We use this formula to find out the spindle speed. Thus, that is equal to surface cutting speed into 1000 divided by pi into cutting diameter. So next term is feed function. So the feed is programmed under an F address except for rapid transfers. Thus, the unit may be in mm per minute or in mm per revolution. So the unit of the feed rate has to be defined at the beginning of the program. The feed rate can be tool function calculated by the following formula. So this is the formula for feed rate. We use this chip load divided by tool into number of tooth into spindle speed. So this is the formula for feed rate. Another function is tool function. So we use or we select the different tools. So the selection of tool is commanded under a T address. So we give a command. We start from T. So T04, if we use this particular word, then means it represents the tool number 4 we are going to select for this particular for some particular operations. Next term is work setting or offsets. This is very much important. All numerical control machine tools require some form of work setting or offset or tool setting and offsets to place the cutter and work in proper relationship. So to make a proper relationship in between those two things, because cutter and work, though both two are most important things which moves with respect to each other. So the compensation allows the programmers to make the adjustment for unexpected tooling and setup conditions. So a retraction point in z-axis to which the end of the cutter retract above the work surface to allow safe table movement in x-axis. It is often called the rapid transverse distance retract or work plane. Some manufacturers build a workpiece height distance from MCU material, and whenever the feed motion in z-axis will required, that will automatically be added to depth program. So there are two methods. First method is a retraction point in z-axis to which end of the cutter retract above the work surface to allow safe table movement. So always there is a prefix values. So whenever we start or end, that always the cutter will move in that position and it will stop at that position. So it is called rapid transverse distance or retract or work plane. Some manufacturer build a workpiece height distance. They always keep that height distance in machine control unit. They feed it whenever the feed motion z axis will automatically be added. So whenever you start, it's automatically added to the depth program. Second method is when setting a cutting tools, the operator generally places a tool on the top of the highest surface of the workpiece. So this is the second method. So manually the operator do that he moves the tool and it keeps on the surface, highest surface of the workpiece, or each tool is lowered until it just touches. So until it just touch that workpiece surface, we may move the tool, then its length is recorded in the tool list. Once that workpiece has been set, it is not generally necessary to add any future depth dimensions since most times you do this automatically. This is manual system. So in this figure we can see the offset. This is the offset of the tool with respect to workpiece. This is the gap we need. If you can say safe or safest gap between the workpiece and tool. So this is the work setting. We do this work setting. So here we can see the tool change position, or this is a 0 for the move to the holes. So before it goes, we keep it at some gap, or this is the work offset setting. Next term is rapid positioning. So this is the command used, or this is to command the cutter to move from existing point to the target point at the fastest speed of the machine. So whenever we need to move the uh, tool or cutting tool at very fast speed, so we use this command particularly so that it can go fast at desired location. Second term is linear interpolation. So in this particular command, this is to command the cutter to move from existing point to the target point along a straight line at the speed designated by the F address. So here we designate some speed so that it moves in linearly, or linear, we call it linear interpolation. So it's moves at a straight line particularly. Second is circular interpolation. So this is the command used for cutter to move from existing point to the target point along a circular arc. So in this way it moves. So either it move in clockwise or anti-clockwise or counterclockwise direction. So the parameter of the center of the circular arc is denoted by the, so this center is denoted by the ijk address. This is the distance in, we can say, from the start point I, or in this vertical distance in j, and I, so we already have seen I, the distance along the x-axis, and along y z, sorry j, and along z direction is this, we call it k. This parameter is defined as the vector from the starting point to the center of the arc. This is the clockwise circular interpolation, this direction, and this is the anti-clockwise circular interpolation. Next term is cutter compensation. This is very much important because as in numerical control machining, if the cutter axis is moving along the program path, so the dimension of the workpiece obtained will be incorrect since the diameter of the cutter has not been taken into account. That is very much important. So what this system require are the program path, the cutter diameter, and the position of the cutter with reference to the anterior. So the cutter diameter is not included in the program. It has to be input. It has to keep in mind what is this. It has to be input in the system in the tool setting process. So there are two methods, one, or we can say two different figures. We can say if we have given tool path without cutter subcompensation, in this we have compensated that tool diameter. So if we, this is our desired, we can say, size, or if we need this one, so if we directly keep this particular, or we will move the cutter in this direction, then we will get, this is will be the final shape, but this will not be correct form. So if we'll compensate the diameter of the tool, then the desired, or whatever we will get, will be equal to what have been, what we have been cut by our tool. So again we have some symbols used during programming. Percentage, this is the main program. L, subprogram represent. N, sequence or block number. LF, block end. T, tool number. D, offset, tool offset. S represents spindle speed. F represent feed. M, switching function. G, transverse commands. R, parameters. I, J, K, circle parameters. B, U, R represent the radius. X, Y, Z, axis coordinates. M, P represent the passes. So in this particular example, we will see one example. We will take the one example of lathe machine for turning operation. So this is our the job we need to do. So it's a lathe operation such as simple facing, turning, taper turning, thread boring. These are the operations to be taken, to be done. The x-axis and y-axis are taken as the direction of the transfer motion of the tool post, and the axis of the spindle to prepare the part program using G code and M codes. The following examples are used. So for this particular operation, we will make the manual part program or prepare. So as a, we will start from N01. So initially we will do parameter setting using this G54Z90, and we will use some kind, we will specify the parameters like spindle speed 800. Again, for facing operation, we will write this program. For retravel tool, we will write this program. For tool clearance, again, to start the cut, then clearance position, then position of the cut. Then for different operations, we will write the codes for cutting length, for retravel position. So same way. So at the end or final position of the tool, we will write this, and we will end the program using N90 M02 program. So for this wall, we can say we will write the program in this way so that we can get the desired workpiece. So this is the one exercise for the who want to learn from this video. They can do some exercise for writing the manual part program using the G codes and M codes.